Hello everybody, my name is Tatiana and welcome to my new video series about OTF Studio thin film software. Very modern, very powerful and extremely fast software for design, characterization, reverse engineering and monitoring of multi-layer optical coatings. Today I would like to demonstrate you how to design anti-reflection coatings, simple anti-reflection coatings for single and dual wavelengths. I would like to design two anti-reflection coatings. One is for the laser wavelength 532 nanometer, and another one for two wavelengths 532 and 1064 nanometers. So here we can see schematic representations of reflectances. So in one case, reflectance is 0, target reflectance is 0, is in one spectral point, and for dual wavelengths, reflectance is 0 in two wavelength points. I open my OTF Studio project, specially configured for this design problem. Here in the center, I see reflectance. This is reflectance of one side of the glass substrate. If I include the back side, reflectance will be about 8%. My target reflectance is only 1 point at 532 nanometer. I will use two materials, titanium dioxide, silicon dioxide. They are loaded. And I will look for a two-layer solution. So I would start with two-layer coating. Two layers with each layer is 50 nanometer thickness. To save space on the layout, I move my environment panel together with Design Builder. And these two panels will be in tabbed view, so I can switch between two panels. Now to start optimization, I focus on the Design Builder panel and choose simply refinement without constraints and start. And of course, I will get merit function 0 because there is a two-layer solution for only one wavelength. And I can save this design solution using results, design, two-layer anti-reflection coating. To design an anti-reflection coating for two wavelengths, I need to load another target. So the target for two wavelengths, 532 and 1064. So I load this target and I see here only one target point because I need to extend the spectral range first. So I open the sliding panel and spectral range is 400, 700 and I increase the range up to 1200. And here we can see now two target points, 532 and 1064. For this anti-reflection design, two layers it's not enough, so I have to load 4-layer starting design. 4 layers and each layer is 100 nanometer. Here is my design cross-section. And also focus on the design builder and start refinement without constraints. Simply run. And merit function will be again 0 because this is there are only two target points and 4 layers. So I can simply save this design as 4 layers anti-reflection for two wavelengths. and commit. So now I have two designs, 2-layer anti-reflection and 4-layer anti-reflection for two wavelengths. Now I would like to open Admittance panel and analyze the admittance of this 4-layer coating. So as expected, this is 532, so this is anti-reflection point. We start with 1.52, so the refractive index of the substrate, and go using these curves to the point of 1.0. If I will increase or change the wavelengths, of course, the admittance curves will change. And if we go further to the point 1064, so this is very close. And now I simply check here 1064. We come to the same situation. So we start with 1.52 and go with these 4 layers to the point 1.0, so to anti-reflection point. If I investigate in angular mode, so more, and we'll consider both polarizations and angular mode with 5 nanometer angular step. So first, we are here at point 1.52, and then I change the angle, and we can see that two polarizations are separating, and it's very nice pictures, and up to 70 degrees we have absolutely different curves. Now I close the admittance panel and would like to investigate angular behavior of reflectance in these two anti-reflection points. So I open angular plot in view ribbon, angular. So this is dependence of reflectance on the incident angle. To specify the spectral point and angular range and the type of polarization, I open the sliding panel. And here I choose reflectance average. So the wavelength 532. Then I add one more point, and this is 1064. So I have angular dependence of reflectance at these two spectral points. Now I close this angular plot, and practically maybe it's more reasonable to specify not one wavelength, 1 and 1, but small ranges for such coatings. So I load my extended targets. So this is plus minus 10 nanometer from these central target points. And if I load my starting design again and start refinement, I will have a coating similar to the previous one, but with more flat behavior of reflectance in the vicinity of the laser wavelengths. I would like to demonstrate more plotting possibilities of OTF Studio. Here you can plot, for example, two different two-dimensional plots. I can now construct new plot. Dependence of reflectance of the coating on the coating coordinates, so on thickness flow for average polarization at 532 nanometer. Or another possibility is to plot three-dimensional plots, like, for example, reflectance, dependent on wavelengths and on the incident angle. So I specified wavelength range, angular range, average polarization, and it will be contour map type of the plot. So commit, and it will be two-dimensional plot that will be also updated when variator, so interactive analysis is active. In this video, I wanted to show you how to design anti-reflection coatings for 1 and 2 wavelengths, and to demonstrate some plotting possibilities of OTF Studio. Thank you for watching. If you have questions, please contact me, and see you in the next video. Bye!